We're going to be using the authentication system basically at page, but we're not going to be using the authentication system. So let's start with that authentication system. Specifically, let's talk about user login and logout. At a high level, the Django API here is pretty simple. There are 3 functions. The first function is called authenticate. It is given a username and a password, and it gives you a user object if that's a correct username password pair. Or it'll return none if it's not a correct username password pair. And note that this doesn't like raise an exception for an invalid password or something. And actually, when you call this function, you don't know whether it's a wrong username or a wrong password or what. This might seem kind of bad from like a usability point of view, because now when we provide error messages to the user, it's hard for us to provide maximally explanatory error messages. We can't tell the user is it the username or the password that's incorrect. But this is for a good reason, which is you don't necessarily want to reveal information about which users exist in your system. So when someone is doing login, they haven't yet logged in. That's why they're trying to log in, which means you don't know who they are, which means you cannot assume they're friendly. You should probably assume they're evil, which means you probably don't want to reveal any information to them. So that's why Authenticate has this API. It'll return a user if login is successful. Otherwise, it'll give you basically no information, which means that the error message you'll provide to the user is probably just like invalid username password pair or something. And they'll have to try to log in again. Okay. Then once you have authenticated as a given user, once you have a user object, you can use these 2 functions, log in and log out. And these work, they're very simple functions. Log in just updates the user's current session data to store what user they're logged in as. And log out updates the user session data to remove the information of what user they're logged in as. So these are the login and logout information. These are pretty straightforward. The authenticate function is a little more complicated. It's got to consider things like timing attacks and hashing. There's also a bunch of support in these functions for things like password resets, or like what if some point down the line you want to update which hashing algorithm you use because of changes in like what cryptography is considered safe. So there's some details in here, and I wouldn't recommend building your own. But at a high level, these are Hey, the weirdest thing is the other one works, so I know it's not. Anyway, so these are pretty straightforward to use. And you can see that at the core, they're not doing anything too complicated. So here we can see what's going on. To authenticate a username password pair, all that it's really doing is it's looking up the user object by the username. That's pretty fast because usernames are unique. Then it's checking the user's password against the password that it's checking the password in the database against the password that has been sent to you in the HTTP request. It's checking whether or not that user is marked as someone who can log in. You can disable a user that's kind of built into the user abstraction. And in that case, it returns the user. And otherwise, it returns nothing. That's that none value that tells you the login wasn't successful. So that's really all that's going on in this authenticate function. Again, there are some details in here and in here dealing with things like password resets or constant time comparisons. So the way we want to handle a login is pretty simple. We'll want to build a login form, which has a field for a username and a password. It should be a post form. You don't want those to be get forms because you don't want to store the user's password in their like browser history in the URL. You got to stick the CSRF token that we always do. You probably want to use type equals password for the password input. That's what makes it show up as like little stars or circles. And you know, you've seen password forms, so probably this isn't super different. And then, yeah, when you get this form submission, you get the username, you get the password, you pass it to authenticate. If that returns none, you re-render with an error message. If that returns a user, you render it correctly. So let's try to do that. Let's build one of these. Let's go to our test app, our template, and build a login form. You'll see I changed the color scheme, so hopefully folks in the back can see it a little better. If you still can't, let me know. I was not intending to lecture only half the class. All right. Let's build a login form. As usual, I'm not going to bother too much right now with styling. So we're going to build a form. We're going to want it to be a post form. We're going to want it to post to some URL like /login, whatever the login form. You'll remember when we talked last week about forms, we said most forms will post to the same URL that you're on, and then redirect away from there. So in here, we're going to want a username, and we're going to have an input name equals username. Say required. Remember this required attribute that's part of this client-side authentication. This is just making sure the user can't submit the form until they submit it. Okay, and then we'll do the same thing, but we'll do password. We'll do type equals password. I'm going to put required as well, because I think probably the password field is required. And it's form. So I'll make a button. All right, cool. So we built a little minimal password form. A couple of things I didn't include. I did not include a button that says remember me. I think this dates back to like the late 90s when not all browsers supported cookies, but they do now. You probably don't need that button. One thing you might consider is a button to show the password. Like on mobile, where people are more likely to. What you might consider is a button to show the password. You can do that in JavaScript pretty simply by switching type equals password to type equals text. I'm not going to build that today because we haven't talked about JavaScript. So we got a little minimal password form. Let's go and build a controller for this. So I'm going to go down here, make a function login form, and in here, since we're going to handle a form submission, we can just build out our little our common pattern where we're going to have a case here to manage form submissions. It will it'll redirect if the submission is successful, if the user logged in, otherwise it will re-render the page. So we can render login.html. I didn't use any template variables, so I don't really need to pass any. And then in here, we're going to get the username is request.post. Username, password equals request.post password. And now we have a username and a password, so we want to log the user in. So remember, this is a two-step process. We first authenticate the username and password, then we log in as the user. So user equals authenticate, request, username, password. Now we got two cases, whether logged in successfully or not. So if user, we want to log in as user, takes request and user, and then return redirect, let's just say page. Otherwise, this else case, this means that the authenticate was not successful. So the user put in an invalid username password pair. So we'll handle that the same way we handle all other kinds of errors. We'll say errors equals, I guess here I'll do an array because they're not actually going to be specific to username and password. Invalid pair. And by the way, anytime you write this, anytime you write an error message, you got to ask yourself, is this the way normal people talk, or is this just the way programmers talk? This is not the way normal people talk, so your username or password was incorrect. So maybe talk like normal people. So now we've got a little error message. We'll want to pass that in. Okay, we can go back to the login form, make sure to print any errors. Back to the list. Okay, so we've built out a tiny little login form. We can check that it works. We just need to do one more thing, which is hook it up to the URLs. And the URL I think I chose was login. Login, use and note here, I call this function login_form because again, login is a Django. Kind of ugly. So let's run this. I probably should just fix it and install Django. Okay, so let's go to /login. We have a login form. It even auto-completed for me. And when I click login, every time I make a form, you forget this. Remember that this error message just means that you've got to go into your template and add this magic text, the srf token. Refresh, submit. Okay. Progress. That's the srf token, by the way. I will explain it on Monday. So we're getting closer and closer to that mystery being resolved. Okay, it's pretty happy. The only thing that's going on is I need to import this stuff. I think it's from django.contrib.auth. Import authenticate, login, logout. Resubmit. Okay, takes from 0, 1 positional arguments. And the 3 were given. That's definitely not the case. Django import. Then I probably just imported it from the wrong thing. Oh, okay. Fine. You gotta pass them as username equals and password equals. Fine, Django, you win. Okay. Try that again. Okay, cool. So it redirected us back to the index page on a successful login. That's not super, that doesn't look correct, but it is correct behavior. Let me just modify it, make it redirect somewhere else. Hello. Also not actually a good idea, but cool. Okay, now it works. So you see that it successfully logged me in. That wasn't very much code. We just built a standard form the same way we've been talking about building forms. And then on the controller side, we use these 3 built-in functions: authenticate, login, and logout. I guess we didn't actually use logout, but if we wanted to implement logout. Okay, so that is our little demonstration of logging in and logging out using Django. Questions about authentication, login, and logout? Okay, great. Cool. A couple of additional notes on this before we move on to authorization. One thing I want to note is that Django does come with this built-in Django admin, and the Django admin has its own login form, and the authentication system is shared between them. So for example, you just saw that I logged in as PavPad. If I now go to the admin page, you'll see that I'm already logged in. So this is kind of convenient or not, depending on how your application is structured. Often the way the Django admin works is it's a way to do some like rarely used actions that it doesn't make sense to build out a user interface. So like, for example, maybe you think it's very rare that someone will need to like change what user a submission was from. But sometimes it happens and might be convenient to do that through the admin. In this case, it's convenient to have the admin and the main site share a login system. I think there's a way to turn that off as well. You can make them separate. The other thing that's nice though, is that there are some kind of less common things where maybe you want to reuse the Django admin. So for example, the change password form, there's one in the Django admin. Maybe your application is only going to be used by a couple of people, like the one that we're building in your assignments. And then maybe it makes sense to just reuse this, like, okay, reasonably nice password form. That said, typically the login form you're going to make your own, just because it's pretty difficult to style the Django admin to look like your website. And you probably want it to. But again, useful for maybe stuff like passwords. As the site gets bigger, you're going to want to customize more and more things, and the Django admin is going to become less and less important. Okay, the other thing I want to talk about is the redirect system in the login. When I implemented this minimal login form, you can see that my success case was to redirect to a specific page on the website. That's not crazy. A lot of websites work this way. For example, you log in and it shows you like your user profile, or it shows you the front page, or it shows you your task queue or something like this. However, it can be kind of inconvenient if the user didn't expect to not be logged in. So like, here's what we got so far. The user goes to some web page, like their profile or maybe some other page that requires login. And then that page notices they're not logged in, and it redirects them to the login. Then you know what's going to happen. The user's going to request the login page, and it's going to render it. And then when the user gets that page, they're going to try to fill that out and submit it as a post request. And maybe if they make mistakes, they'll get re-rendered. They'll go through this loop again. And now they finally logged in. Where does the user want to go? The user ideally wants to be sent back to the very page they were trying to access to begin. And you've probably seen this. If you log, well, let me do kind of an example. Let's go to GitHub. And I'm going to log out. So now I am signed out from my account, sent me back to the front page. And now I'm going to try to view one of these repositories. I'm on this page, and I'm going to try to log in, right? Maybe, maybe I want to view a student repository, right, for my solution. So I'm going to go back here. I'm going to log in. I'm going to do my two-factor authentication. Probably should have chosen a website without it, but second. And then you see that when I logged in, I went back to the page I was on, right? This is a flow that you've seen a lot, and I want to talk about how to implement it, because this is a pretty useful part of usability, and it's something you're probably going to want to implement almost any website. So here's the challenge. We want to redirect to the user to the same page they were on before. But to do that, we need to pass information about what page they wanted across at least 3 requests. Over here in this first request, we know the user wants the profile page. We need to know that as they go to the login page for the first time, and as they submit it, so that we can redirect them to the right place. So we need to pass this information that the user was looking at /profile across 2 separate steps. So let's talk about how we do that. Let's first add a page that the user can only view when logged in. So maybe this hello view is fine. So let's first make sure the user is logged in when we view this view. So a simple way to do that would be if request.user.is anonymous return redirect / So this is an easy way to protect this view, make sure that the user is logged in. However, if we do this, then when the user goes to /login, where's the information gone that the user was looking at /hello? We need to preserve that information. So here's the way we can do that. We're going to add a get parameter to this URL. so that when the user visits the login page, the browser sends along information about where they were trying to get. So I'll do that like this. I'll say next, that common URL parameter, /hello/ something like that. So what I've done here is I've taken the URL they were visiting, which is /hello/text, and added it as a parameter to the read. So let's go back here, /hello/tabpan, and I'm going to open this in a private tab so that I won't be logged in. So you can see that I've now been redirected back to the login form because in this private tab I'm not logged in. And you can see that the URL in question ends with next equals /hello/path. Okay, cool. Now we need to think very carefully. There's a couple of steps involved here. We are now in this login form controller. So we've got the /login. And we have a get parameter. So we can pull that out, .get. So here I've given a default value to this parameter. If there isn't, for whatever reason, no next URL, if the user goes directly to /login, then we'll just have a default. This application is weird because we never figured out what it does other than host my examples. So we'll have some default. Okay, so now let's go back to the diagram. We've now taken the information that we were trying to go to /profile, communicated it through this request sequence. So now we're in the login controller for the first time, and we know that we want to go to /profile. But there's a step in between. Since we are visiting the login form for the first time, we're going to render a form, and then the user will submit that form. And this is the point where we decide where to redirect. So we need to pass this information, this next URL, through that request process. The way we do that is with a hidden input field. I'm going to open up the login form, and I'm going to add an input with type equals hidden. A hidden input field does not show up at all. That's why it's hidden. However, you can give it a name and a value, and it's submitted along with the rest of the form. So I'll give it a name of next and a value of next URL. And we'll pass that next URL in here. So let's take a look at that. I'm now going to reload this page. This is that login form with a redirect to /hello/pevpen. And if I open it up in my browser DevTools and I bump the font size of the DevTools by a lot, you can see that I now have a hidden input field. This is the one I just generated for that same next variable and the value. So basically, I first had a request to /hello/pevpen. I propagated that information to the login form using a get parameter. Now I put that information into the form with a hidden input. And now, when I go to sign in, let's observe the login information. Pevpen. Now, when I observe this login information, you see that I will be submitting that next URL as well. Okay, so now when I'm processing the login, when the user has typed in the username and password, along with that, we're sending a next URL. So that means that if over here, we now have a next URL over here, when we're processing a post request, we are going to get a next URL as a post parameter. And then when we redirect, we can redirect directly to that next URL. Okay, so this is fairly complicated. So let me just walk us through this whole process again. The user first requests some page they need to be logged in to see. That's over here. And we need to enforce the security policy, user must be logged in. We do that by checking request.user. You remember request.user is either a real user object or this weird thing called anonymous user, and you can check is anonymous. So if the user isn't logged in, we want to send them to the login form. And when I do that, I save information in the URL, in the get parameters, where they were trying to get to originally. By setting up this redirect with a get parameter in the URL. That sends us to the login form with a get request. It's a redirect. We can grab that next URL out of the get parameters and put it into the template. In the template, we put the next URL in a hidden input field. When the user submits the form, the browser is going to find that hidden input field, send it to us in the post request. So now when we receive the post request, we can pull out that next URL again. And finally, we use that to perform the actual redirect back to wherever the user originally was looking. So maybe we can actually test this with GitHub. Let's go to github.com/utah/CS3550/4/solution. That's a hidden repository that it's supposed to see. Okay, actually, okay, fine. GitHub's a little different because it'll actually have the form on the same page. It hasn't performed a redirect. But I'm guessing that if we open up that form, we'll find a hidden input field somewhere in there. So we have this form. And we have a number of hidden input fields. See if we can find a lot of them. Yeah. So here you got the one input field, and this one is called return to. And the value of that input field is the URL that I should be sent back to once that form is. So their situation is a little bit different just because they have the input form on the same field. They don't have to do this get parameter step. But again, they're using this trick of using a hidden input field to store in the form where the user should return. So questions about this flow? Yes.
Does this work the same for just a normal sign-in button or login button?
You mean if the user didn't start with a particular page?
There wasn't a pop-up, you just click on sign in on a specific page.
Yeah, if I just click sign in right here. Well, first, the URL here has that same return to parameter. So again, that sign in button, this is a nice thing GitHub did. If we, apologies, I have to keep messing with this, but I want to keep the font size big so people like that can see. You can see that that button is actually a link element, and it's a link to /login !return to equals, and then that same URL. So the same functionality, the same exact technique that we just implemented in our application, except they called it return to. That's literally it. Other questions? Yes, I'm back.
Does Django have a method to escape any other get parameters that you want to have in the URL?
That's a great question. So what you're kind of pointing out here is that over here. Here I'm constructing a URL by doing some string manipulations, which is not like super safe in general. So first, yes, Django does have features to construct URLs given get parameters. There's a function called URL, and you can use that. But the other thing that I should note is, I think it's in contrib.auth. There's a require login, I believe that's what it's called. And if you write @require login, this thing is called a decorator at the top of your function. It's exactly the same as having this, but with the correct escape. So on your homework assignments, what I think you will actually be doing is using this small shortcut.
When you're creating workflow like this, and you're dictating how tasks can be formatted, is that formatted on the CSS or HTML side, or?
By formatted, do you mean Like the fact that it shows up as stars, or do you mean password requirements, like must be at least so long, must be? Yeah, so if you have password requirements like that, you're probably gonna enforce them when you like create a user or change passwords. And you know, it's normal code, so like, you're totally free to have a view that's like, create user, and then you're probably gonna get a username. Probably gonna look something like this. And then you're probably gonna say, probably gonna have an errors dictionary. And you're gonna say if len password less than 8. Password. I don't know, passwords. Must be, please. And then you could say like, if not any C dot is digit password. Password must contain a number. And et cetera, et cetera. If you have any other requirements like prevention. So this is normal, this is exactly the way that you do any other kind of validation, right? You got a form submission, someone wants to create a user or change a password, and you have some particular requirements on the password field, like it's gotta be so and so long, it's gotta be this, it's gotta be that, can't be one of the last 3 passwords, et cetera, and then you just do that. You know, like a separate question is how do you design those rules? And you know, these best practices kind of evolve, but typically there's some minimum length requirement. Pretty common that people want to prevent common passwords, like the word password. Or another very common one is A, B, C, D, E, F. You know, like the first couple, 1, 2, 3, 4, 5, 6. Let me in, actually another very common, widely used password. Yeah, so you probably want to prevent people from using these because then it's going to be really easy for an attacker to guess. Django has functionality for creating users, and its user creation stuff will check that you have a user, that the password follows these features, and will give you these verifications. So if you kind of like, if you have some specific rules that you need to implement because they're like, I don't know, required by whoever your employer is, then you can just go ahead and implement them right here. If you just want to know kind of what are best practices, I use what's built in. Yes.
How does the require login decorator know which URL to redirect to?
Yeah, great question. That's because these decorators do some funky stuff under that. So specifically, the decorator looks up the function it's decorating in the Django URLs to figure out what the URL is.
Okay, but like, how does it know, like, because you could have different like login URLs, right? So how does it know which?
Yeah, great question, great question. That is because I wasn't gonna cover this in class, but it is in the homework where you have to do this stuff. Somewhere in here, you gotta specify, I think it's login URL. So somewhere in here, you do something like login URL equals login. Actually, probably without the initial slash to change. So there's some kind of, there's like a config parameter.
How do you time out like a user that it's not active?
Great question. So we talked on Monday, when we looked at sessions, we saw that there's a default expiration date. There's a default expiration date for a session, right? So there's kind of 2 questions you may be asking. One is, how do I end a session? And the other is, how do I log all sessions for a given user account? And those are 2 separate questions, right? Imagine I have like, you know, imagine I buy a new phone, but I still have the old one. Well, you probably want the phone has a session active. With like a cookie that could log into certain websites. And you probably want to expire that session. By default in Django, that timeout is 2 weeks. I know that that's configurable, but I don't know how. But I'm sure you can look it up.
But like, so how do you log out of like a session? Like you don't expire the session, but the user's not actively doing anything and have their, you know, web page logged in.
Okay, so remember the mechanics of sessions, right? The user makes a request to your page. And when they do, there's a cookie attached. And you will look up that cookie in the session database to figure out what user they're logged in as. And when Django does that, it'll also check that expiration date. So if that expiration date is passed, any requests with that session ID, you just won't load the session information, they'll be locked. You're looking at me like that wasn't the answer to your question. Maybe you can reformulate the question somehow, or maybe I can explain it better.
Well, is, what you're describing right there is exactly what happens if you like open up Canvas, come back 6 hours later, and then click on a page. and
Right.
It's time you out.
Right. So to be clear, your browser doesn't know that the session has been expired. Right? When you want to end a session, you're not reaching into the user's browser and like messing. The session lives on your server. The only thing the browser has is identity documents. Yeah, you know that passports expire, right? So if the government for some reason wanted to like not let you leave the country or enter the country or something, the government doesn't have to like confiscate your passport, right? What the government does is it just says like, hey, the passport's expired, you still have the physical object, it still proves that you are you, it just doesn't work. And we're gonna do the same method to expire a session. So the user gonna come to you, they think they're logged in, but when they make a request to your server, you say, hey, I looked up this session's already expired, so I'm gonna treat you like a not logged in user. So that's if you just want sessions to expire after a while. There's more rare things you might wanna do, like log a user out of all of their sessions. Like if, for example, a user changed their password, and Django does, oh man, that's finicky. Django does have some functionality for this, but I think that's kind of rare. I think you're asking about just like a user hasn't used a device in a while, and you want that device no longer to be logged. So you don't change anything on the browser. On the server, you just mark that session as expired. And Django will do that by default. It has an expiration date for each session, which I think is 2 weeks from last use. And you know, past that point, Django just won't use that session. That still looks like not the answer you wanted, or not an answer to your question. I'm gonna get more, and then we'll come back, okay? Yes,
If I'm asking that, I think it might be a little bit similar. Assuming we go onto a bank's website,
yep,
and presumably banks don't want people to like walk away from the computer for too long. So
That's
maybe like after 5 minutes of not touching it, you get a pop-up comes and says, hey, are you still there?
right.
Is that also done via sessions or is?
So that we can do, we probably wouldn't do that directly. Okay, there's more to it than a session. Remember that the user is going to go to your website. That's the first request, that loads the login form. Then they're gonna make the second request once the login form has been filled out. What we wanna measure is the gap between those two things. Right, they were away from their computer for too long. So that one, we can do fairly directly. We can go into our views. So we're gonna wanna remember when the user loaded the login form. So we can do something like request.session, login form loaded equals date contact. So here I've saved the time when the login form was initially generated or initially loaded. And then when the form is submitted, I can say, loaded time equals this, current time equals if loaded time. Let's see, bigger than current time minus, it's what, like 60 seconds per minute times 60 minutes per hour times 3 hours, let's say. I don't know. Maybe you want 3 minutes, you know, you could do this however. Then errors append. Try again, but not that error message, but you get the idea. You put an error message here. We'll want to make sure that we can't log in the user if there are errors. All right, so we've here we've used the session, that's something stored on our side, on the server, to record when they first loaded the login form. And then check that it hasn't been too long since that time. And this is safe, remember, stuff that's stored in the session that's stored on our server under our control. So we are just looking at when they loaded the form, and then we see hasn't been too long since that time. So you can implement that kind of function. Other questions? Yes.
Can you make a cookie invalid on your own server side, even if Django thinks that it's still valid?
You can quite simply do request session equals this, and you have deleted all the session data. So again, the cookie, that's something stored in the browser with a random identifier. But what we care about isn't the identifier, it's the session data. That's stored on our server. We have total control over that. And if you want to clear it, yeah, go ahead and clear it. So this, for example, will just delete any information that we have about the current session, including like what user is logged in. And then the user will be logged in. And by the way, this is basically exactly what the login function is. Other questions? Yes.
So, regarding maybe logging out a user, if their cookie is long out, if it's been longer than specified, how does the server continually check or without calling the function?
So you're getting that cookie that identifies the browser on every single request. So every single request that comes in, Django looks at that cookie and decides, what does this cookie mean? Does this mean that the user is logged in? Does it mean that the user has certain privileges, or does it not? So on every single request, Django is making that determination, including the determination of like, hey, is this login expired?
Well, I think what we're saying is that there has to be a request made for Django to check. So is there a way for there not to be a request made that still checks?
Well, if the user is not making a request, they're not using your website. Sure. I mean, yeah, I think this is kind of a philosophical question. Is the user logged in if they cannot use their login for any purposes?
No, but let's say your email.
Yep.
Sometimes time zone just logs you out. How does that function?
Oh, you mean you have the web page open and just at some point it kicks you out? Yeah, okay, got it. Excellent. Okay, glad. So to do that, you're gonna use a little bit of JavaScript. So you're gonna, when you generate the page, you're gonna store some JavaScript data saying when the user needs to be kicked out. And you'll have JavaScript that checks that every now and then and kicks you out. We haven't talked about JavaScript yet, but I don't know, there's a JavaScript assignment, I'm gonna make you implement this. But sorry, more importantly, you'll do some JavaScript. So JavaScript is code that runs on the user's browser. We can't do that yet because we're not running any code on the user's browser, we're only running code on the server. If the server isn't getting requests, it's not thinking about your user. You can't spend its time thinking about users who aren't using it. Yes?
Typically for the login page, if it's not, if there are, wouldn't you check if they're logged in? If they are, you just redirect them.
Sure, yeah, you can do that. So if you could do if request user if user is not anonymous, then yeah, you can do this. That's fine. Other questions? Yes.
So is there a way to protect against changing the next URL value that's passed into? So if somebody goes in and changes that?
Phenomenal question, which I'll answer on Monday. This is a classic security vulnerability, one that we will be discussing as our 3 classic security vulnerabilities on Monday. Other questions? Okay, I'm going to move on because I think it is about time to do so. So we've now built a login form. We've even got this sort of complicated login redirect system working. And I'm going to skip a couple of slides, but they just walk you through implementing the same thing I just did live. So now the user is logged in. And what we now need to do is authorize the user to perform certain actions. We need to know, in other words, can the user do X, Y? So at its core, this is kind of a function that takes an action, a user, and tells you true or false. That's what we're talking about here. So when we're talking about authorization, we're talking about what's a convenient way to write these functions in a way that minimizes errors. So that's basically what we're doing here. Every time a request comes in, we can look at the current user, we can decide, are they allowed to do what they want? So if we go back to this sort of test application that we built throughout the class, you can see here that I have a student add function, which I suppose lets me add new student objects to the database. And one thing that I might want to do is I might want to restrict this only to the administrative user. So I can do that by saying if request.user.is anonymous or elif request.user.username not equals pevpen, my super user account. I don't know, raise permission denied. Only the professor. Okay, so fairly simple. I need to import permission denied. Django.core.exception. All right. I might need to create some student objects other than some user objects other than that. So let's go to the admin. And did I stop it from running? Okay, I'm imported require logins, but so it's not what it's actually called. I'll leave that to the homework assignment. I'll tell you what that function is called. Okay, let's create a user. I'm going to create a user named Bob with password Bob. Bob. Save. Okay, yeah, all right, fine.
Well, we're in.
I put in a long password that I happen to know that I really hope won't be printed on the screen for y'all. Okay, great. Excellent. So I've created a username, and you can actually see good news. When I created the username, it's not showing the password, and it's also not saving the password in the database. Saving passwords is kind of like a bad idea in general because users tend to use the same password for many sites. You can say that's their fault, but everyone does it, so you probably still want to do something about it. So you can see that what Django is actually storing internally is some kind of hash that you can determine that you can match against the password, but you can't get the password. So I've created this user Bob, and now I want to make sure that in order to go to the student's add page, you have to be both signed in and you must be the user pevpen. So let's test that. I'm going to go to student add, maybe students add. Okay. Oh, because I added a required post. All right. Well. Oh, it worked. Okay, that's request method post. This is probably from before we talked about forms. No, else. You're in. Okay, and okay, cool. All right. So the point is right now I'm passing those tests because I'm logged in as the user pevpen. Let's do the same thing from an incognito tab. Oh, yeah, because I said redirect . We probably need to fix that. We probably need to say login next equals student. Okay, so do that again. I'm gonna go to this URL. in my tab. Now it sends me to a login form. And instead of logging in as PathPan, which would work, I'm going to log in as Bob. I hit login. It's this login required. It's this login form. I'm gonna, oh yeah, because I cleared the, I'm gonna remove this loaded time. Okay, so now I successfully logged in and redirected me to /student/add, but I'm getting this 403 forbidden, and that is because I am now being sent back to students add. The user is not anonymous, but it also isn't PathPan, so this permission denied issue is happening.
So probably we don't want to hard code users for everything. What's like the, how, you know, like.
Yeah, great. So now what we want to do is we want to make these checks, which we're writing by hand. We want to make them something a little more reusable. So let's talk about good ways to write these checks so that you can sort of remember what they're about. So there's a couple of ways that are like really common that you'll use a lot. So the first one that you'll use a lot is testing group membership. So Django provides a feature where each user can be in a number of groups. At the very least, a group that you'll use a lot is super user. So this is like the admin. And then in your grades application, we've set up two groups of users, students and teams. So your grades application, the one that you're using for your homework, typically has four kinds of users you think about. Users who are not logged in, so anonymous users, students, TAs, and the professor or the editor. So that's one thing that works very frequently. You will often have multiple groups of users on a website. It might just be users and admins. It might be like users and moderators and admins. It might be not logged in users. It might be like buyers versus sellers. A couple of different options there. So this is how you can check whether a user is in a group. Here we take request.user. That's a user object. We look at its .groups. This is much like group set. This is one of these like foreign key reverse things. And then we can filter that to check whether there are any groups that this user is a part of that are named a certain thing, and you check whether any of those exist. So this is one simple way that you can check if the user is a member of a certain. So here, instead of doing this username check, we might instead say user.groups.filter name equals, admins or something. So then I need to go into the Django admin. I need to create such a group, and then the user will be part of that group. And that's one way that you could let a user do it. That's one thing that's very common when you're doing authorization. You just have groups of users that all share a certain permission, like can or can't do a certain action. Another thing that you will often be doing for authorization is you'll be explicitly testing whether the user is a specific user. So for example, in your grades application, you probably only want the author of a homework submission to be able to view it. So you'll do a check like this. You'll check, is the current user the author of this submission? And if so, you permit them to do something, otherwise you don't. So these are two very common patterns that you'll do. And of course, you can imagine more complicated options. Like in reality, you probably also want the grader for a submission to be able to view it. And you probably also want the professor to be able to view it, but you don't want other graders to view it. So you can mix and match these kinds of things. Now, in general, your security policy, honestly, security policies are not that complicated. At Dropbox, I wrote a bunch of the authorization logic, and I think there were like 20 total actions that we wanted to permit or deny. And there were like 4 groups of users, if you don't include like not logged in users. So I guess 5. So this just isn't that elaborate, right? You've got a couple of different of these if statements, and they're fundamentally not that hard to write. So I'm not going to say too much more about writing them, but I will talk more about organizing these tests. Because the important thing about authorization, it isn't writing these correctly, which hopefully you can do by thinking carefully. It's making sure you do all the tests, all the places you're supposed to do them. So that's where we want to move on to how do we make it easier to do this kind of authorization? Oh yeah, see, I thought it was require login, it's called login required. Thank you so much. Okay, so the first thing that we have is we have a couple of decorators that Django provides. So there's two ones that you'll use commonly. One is login required, which just requires that the user is logged in. And another is user passes test. And you can combine these. So for example, here in our code, what I might want to do is I might want to define an isAdmin function. That will copy and paste this code. Except instead of request that user, we just check ordinary user. And then I could say at user passes test is admin. We can remove this part right here. I think these don't have to explicitly raise a permission that I would just like to say. Nah, yeah, you raise it. And we have to import them from somewhere. Login required. Is it in shortcuts? Decorators. Does that work? And I can go. Where do you import login? Yep. Django doesn't shortcuts, is that where it's from? No, Django contrib auth decorators. All right. Django.contrib. Okay, this worked. And now we should be able to go to students add. All right, cool. So now it worked. When you're using these, it's going to require you to have that login URL set up in the settings. So let's do that. Settings.login here. Settings. That works. Or does it need no slash? Okay, yeah, it did work. I think. Too many rewrites. Oh. Let's move this part that auto rewrites. Okay, cool. So I was logged in as Bob, and I didn't pass the test is admin, so I got redirected back to the login form. And if I log in as PavPan, I get some here. Maybe it does not. Oh, yeah, because I don't actually have a group name that means. Okay, yeah, so for now, we'll go back to the old one. All right, so let's log in as PavPan, and it should allow us to see this. Okay, so just as a recap, all that we've done here is I've taken this authorization logic, instead of being a random if statement inside the controller, I moved it to a separate function and one of these decorators. And I can do the same thing here by making this a login required decorator. So this is the first step. This is just making it easier to write these tests. And specifically, it's forcing you to factor them into separate functions. This way, hopefully you'll have only a couple of these functions. And if you have only a couple of these functions, then you'll make sure not to have duplicates that have slight differences.
So there's the login required decorator, does that make you log in every time you add a student, or do you just have to be logged in?
You have to be logged in order to visit this page. Okay. So it works exactly like this code that I deleted, that checks if you're logged in, and if you're not, it redirects you to the login page. Okay. Literally exactly what it's doing, except like, slightly more configurable in the sense that it's like looking up what line. Yes.
Why does the login require and know what page to rewrite?
You mean on the, which page hosts the login form?
No, if you're not logged in.
Oh, yeah, because it knows what function it's decorating, and it can look that up in the URLs table. So it's using a little bit of this URLs.py file that stores the URLs to know where. Other questions? Okay, cool. So we've done the first step. We've moved our actual authorization code into a separate function. And that's valuable because you're probably not going to write two isAdmin functions the different subtle ways. But the general principle here is that any time that you want to do authorization logic, it's helpful if that authorization is centralized. If it's all in one place, instead of being spread through a bunch of different controllers. One thing that I find convenient is to put these together with the models. It's pretty common that your authorization logic depends on the particular model. So let's do that here. I'm going to take this isAdmin function. And if you look at these two here, you can see that this implicitly is saying, in order to be able to add students, I must be an admin. This is a pretty natural way to do it, but you can make it a little more foolproof by placing this, for example, in student. And what I'm going to do is I'm going to define a def can add. So I'm going to move this isAdmin function over to my models file. If you have a very big application, you probably don't want these in the model file. You might want a whole separate file. But what I'm trying to do is I'm trying to move them out of the controllers so that in the controllers, all you need to do is check these fairly simple decorators. So here, for example, I will say student.can. And now, hopefully, this is a very easy 2 lines of code to audit. It literally says, you can go to students add if you can add students. And so what we're trying to do here is we're trying to make it as easy as possible to check that all the authorization checks have actually been performed. I moved them to the top of the function. I renamed them so it's really obvious what policy I'm implementing. So in the controllers, I can quite easily check whether all the authorization logic is done correctly. And then on the other hand, in the models, it's very easy to check what my security model actually is, or security policy actually is, and whether I've implemented it correctly. So I'm trying to separate concerns. When you're writing the controllers, you're not thinking about the security policy, you write the security policy separately and use it to do these. Okay, questions? Okay, I want to take one more minute to emphasize this key thing about authorization. The way you mess up authorization is you forget to do a check that you're supposed to do. You check the wrong thing for a certain request, or you got multiple checks in multiple places. They're supposed to be the same check, but they're subtly different. These are really easy mistakes to make. We're all human. It's fine. The way that you combat this, though, since you don't in fact want there to be security bugs in your application, is to centralize your security policy. In simple apps, I think the models file is a good place to do it. In more complicated applications, you might have a whole separate security.py file that stores all the security security policy checks. And then in the controller, centralize it to right before the method as few as possible of these decorators that can check all the properties you want to check. So this is kind of our main approach to ensuring this is kind of our main approach to ensuring we've done the authorization correctly. Deduplicate, put it in one place, and make it easy to audit that you've done it correctly. Questions about that? Great. Okay. So this is kind of the pattern. Here, I've added these as methods to the model. We have a can view and a can submit. And you can see that here, I've done that authorization logic that I talked about. So for example, here, I'm checking if it's, this is quiz.canSubmit. So this is whether you can submit to a specific quiz, I guess like take a specific quiz. So it's testing, has the user not submitted to the current quiz? Checking, does this user's list of submissions have a submission to the current quiz? And if so, don't allow. So again, I've moved this authorization logic. This is a fairly complicated bit of authorization. This is saying that you can't submit a quiz twice. But you can see that these others are doing things like, checking if the user is in a certain section or something like that. Like if a quiz is assigned to a certain section of class. Again, the actual authorization code, these are just performing the same Django queries that we've been performing kind of throughout the class. And the main thing I'm doing is I'm moving these as helper methods into our models so that it's really easy to audit. Did I? Okay. Yep. Another thing that you could do, this is another style, it's not the one that I prefer, is some people like to put the actual tests inside helpers on the model. So you might say that each controller should call a method on the model, and then that method on the model should take in the user. I think this is somewhat common, but the problem with this style, while it does help avoid mistakes, now it's literally impossible to submit a quiz without passing the authorization check. It tends to make it really hard to generate good error messages. Because now kind of any method that you might call might deny your permission and raise some kind of problem. So I typically prefer this style where I've centralized my security policy in one place. But then I'm explicitly called. Okay. And a final thing that I want to talk about is kind of how does this scale? Oh, yes, you have a question.
Sorry. How do you raise an error in the models? Is it the same?
Totally the same.
Okay.
The models file is ordinary Python code.
Yeah.
And if you define a function, it's just a function. You just got to remember to import whatever exception you're trying to raise. But otherwise, yeah, it's totally. And the reason I'm using the models file here, in many applications, your models file is fairly short. Your controller file is really long. So if your authorization, probably all y'all's homework assignments look like this, right? Your models file is probably like 20 lines or so. And man, I've seen your controller's files, it's like 100, 200 lines. It's much easier to check, did you write 30 lines correctly instead of 200? So all I'm trying to do here is I'm trying to move the authorization logic, which you do want to make sure is correct, to a place where it's easy to find, easy to read all of it, and make sure it's done correctly. So again, that's the benefit of this style. We've moved all the authorization logic in one place, and we can just read and check. Other questions? Cool. And I hope, yeah.
Yeah, like what is the best way to debug when you're going through all this? So you're like using the browser as your debugger, usually?
Yeah, I mean, a tough thing about security is that it is difficult to unit test security. The reason it's difficult to unit test is you can write down a bunch of scenarios and check that they work. But this doesn't guarantee that every scenario works. And for security, unlike software correctness, it really, really matters that every possible scenario works. While I was at Dropbox, we had a bug. This is public knowledge. It was a big crisis where the password wasn't being checked. This is a pretty bad bug. It was live for 4 hours. Yeah. This is a big problem. I can't say too much about this bug under the terms of an NDA. However, I didn't do it. I didn't do it. Okay? I didn't do it. I can probably tell you that. However, you probably would write a unit test to make sure a user can log in. There's a pretty good chance you wouldn't write a unit test to make sure an invalid login doesn't work. Obviously, Dropbox has that unit test now, but it did not at the time. You wouldn't necessarily think to do it. So when you talk to security people, the gold standard in security isn't I wrote a bunch of unit tests. It's undergoing an audit. And what does an audit mean? It just means you pay someone a lot of money to read all of your code. And that's really painful, but this is the best method we have for ensuring that you've, in every possible case, followed your security policy. Now, obviously, read all of your code is a painful thing to do. And the way that you can make this easy and worthwhile for you is to make it so that as little as possible code needs to be read to guarantee your security policy. Right? So by doing this kind of centralization, like here, you only need to read these 3 lines of code to know that I've implemented the security policy I have for adding students. Maybe you need to read these 3 lines of code, and then you also need to read these like 6 lines of code, but probably you're going to have many more controllers than you have these can XXX methods. So you're reducing the amount of code you need to read. And that's like, you know, if you were undergoing security audit, that's something an auditor would look for. They try to figure out like, what's all the code that could be relevant from a security point of view. And you would like that amount to be really small. And then they would read all of that code, and then they think very hard. This is what you pay them a lot of money for. And then they tell you, here's a bunch of things you did wrong. So yeah, again, you know, you can test this in the browser. Obviously, as you're writing the code, you're trying to log in, trying to log out, making sure this works. But you know, at the end of the day, if you actually want your security properties to hold, we don't at the moment have a way, this is something I do research on, we don't at the moment have like a better way in general than like read the code very carefully and think very hard. Okay, we're getting close to time. So I want to say a quick word about cases where authorization logic gets more complicated. In this lecture, I sort of acted like actually writing the authorization code is the easy part. The hard part is centralizing it, making sure it's easy to use. But there are a bunch of complicated checks. So for example, you folks probably don't know, but there's this application called Facebook. It's like Instagram, but for old people. And one of the things that you can do on Facebook is you can be someone's friend, which is probably like something on Instagram I wouldn't know. And then there's a bunch of like posts or images that can be set to this permission, friend of a friend. This means this post should be viewable by anyone who is friends with anyone who is friends with the person who posted the post or image. So now we have kind of a weird thing. This authorization logic has to check, is user A friend of a friend of user B? And you can imagine more complicated versions of this. You're checking some kind of graph traversal. This is the point at which you have more complex needs for authorization. Because the naive way to test friend of a friend is to look all of your friends and then check all of their friends for whether, you know, the user in particular is one of them. And that's going to be slow. Right? So, you know, Facebook, well, I don't know, but I assume has some more efficient way of doing it. So they have a service that can perform these graph queries more efficiently. And in that case, there might be quite a lot going into this friend of a friend check. There might be caches for common users and things like that. You know, for example, if you know Taylor Swift posts something on Facebook, presumably she has a whole lot of followers on Facebook. You don't necessarily want to be like redoing a graph traversal every time. So you probably want to cache, you know, who's friends with Taylor Swift and is allowed to see our posts, especially because probably a lot of those posts are public and just like block a certain subset of users. I assume a fairly small one. So again, when you're doing these complicated checks, or actually performing the authorization check requires some complicated algorithm. That's one place that you're going to want to do a lot of performance optimization because you're going to be doing these checks a lot. Another common case that you're going to be doing this is with enterprise single sign-on systems. So here, whether or not a certain user is permitted to do an action might require talking to some other service. So for example, when you log into Canvas, you get the student view. When I log in, I get the faculty view. Canvas probably asks University of Utah to tell it who's an admin, who is a student. So here, again, you've got this more complicated authorization system where you're talking to a remote server. That can be slow. So again, you're performing caching of various kinds.
Is that like why Canvas will usually have this be redirected to the Utah sign-in?
Absolutely. Yeah, and then there's a protocol under the hood so that when you sign in, Utah can tell Canvas, this person is signed in as such and such user, probably active until such and such, because probably University of Utah has its own expiry system for sessions. And here's a bunch more information about that user, like whether they're back. So yeah, at this point, you are building what's called an authorization service, and you've probably got all sorts of features on top of it, like caching or clever elements. And if you're interested in that, that's kind of beyond the scope. Okay, folks, we're at about time. Today we talked about how to build login systems, how to authenticate people, and then we're talking how to build authorization systems, especially auditable ones. So, we'll talk about file uploads and security on Monday, and I will see you all then.
Yo, isn't file upload, isn't that part of our, is that phase 5 or something?
It's not a current.
Was that